And series, we'll talk about sequence today. We'll talk about series tomorrow. Whenever we have geometric sequence, basically that is very similar to arithmetic sequence, but the only difference here is whenever you have arithmetic sequence, you are either adding or subtracting by a common number, whereas with geometric sequence, you are multiplying by a common number. So it says, tell whether the sequence is geometric. If your ratios, so we had a common difference, now we have a common ratio. Okay, we call it a common ratio because we're always multiplying that value, regardless if it is a fraction or if it is a whole number. So if, like on the first one, we have 6, 12, 8, 6, 12, 20, 30, and 42. We look at each value. We are looking to divide here. So we're going to take the one that's deeper into the list and divide it by the one next to it, or the one preceding it, or before it. So we took 12 divided by 6, we got 2. We do the same thing. We go to the 20, we come back to the 12. It's not 2, so it's not going to be geometric. Okay, it's not going to be a geometric sequence. Whereas whenever I take 64 divided by 256, don't always take the higher number. This is why we will have a number, even though it gets smaller, so you will have, if your numbers get smaller as the list goes on and on, don't think of it as dividing, but as multiplying by, in this case, a fraction. Remember that dividing by 4 is the same thing as multiplying by 1/4. Okay? Because whenever we write this out, we don't write it out as a division problem. We always write it out as a multiplication problem. Okay? Whenever we write it out as a multiplication problem, that means that we will have basically an exponential function is what we're getting to. So it goes 5, 15, 45, 35. Is this a geometric sequence? Are we multiplying by a constant term the entire way out? Yeah, what are we multiplying by? 3. Okay, so all we'd have to do is just check to see, is 5 divided by 15 the same thing as 45 divided by 15, which would be the same thing as 135 divided by 15, or not 15, excuse me, 45? Yes, everything's 3. So it is geometric. Same way on the second one, we have 88, negative 44, positive 22, negative 11. Okay, so I need to check by saying negative 44 divided by positive 88. Is it the same as 22 divided by negative 44? And is that the same as a negative 11 divided by a positive 22? Is everything being divided or multiplied by the same value? Yeah, what is it? A negative 1/2. Okay? The hint here is if it changes from sign flipping back and forth, it's going to be negative. Okay, so it is geometric. What about the third one? 12, 9, 9/4, 27 over 8. Is 12 over 9, or excuse me, is 9 over 12 the same thing as 9/4 over 9? What is 9 over 12? Yeah, or 3/4. Okay, so that's the same thing as 3/4. Whenever I multiply here, it's only 1/4. Okay, same way if I go into 27, 27 over 8 divided by 9 over 4, it's going to be 3/2, so it's kind of all over the place. So then the third one is not going to be geometric. Now, whenever we actually write rules for a geometric sequence, again, we're doing the same thing that we did before. We have a certain formula or rule that it is going to fit. I will tell you that geometric sequence is going to be easier than arithmetic sequence because you have to, again, know two things. You have to know what the first term is. That's been key here pretty much throughout. And then you have to know what the common ratio is. The biggest question that I get whenever we do this is that all I have to write? Yes, that's all you're going to have to write. In some cases, it's just going to be your first term times whatever your common ratio is to n to the n minus 1 power. So in this, whenever we do it, so like if we go on to the next one where we actually have to write the sequence, I need to know two things. Remember that my rule, again, is a sub n equal to the first term times r to the n minus 1 power. I always put the parenthesis around my ratio.
Can I have Lauren Taylor for one?
I will always put a parenthesis around the ratio because if I do that, then I can keep everything separated. You will not multiply the ratio with the first term. You will have two values there. Okay? So again, it's really as simple as what's the first term? What's my ratio? The ratio is going to be the hardest part. Okay? I'll just tell you that right now. Because what's the first term? 27. What is my ratio? 1/3, right? 9 over 27, which is the same thing as 1/3. So then whenever I write this out, I'm going to write my rule of a sub n equal to first term, that's 27, times 1/3 to the n minus 1 power. Just leave it like that. What about on 2? What's my first term? 2. What's my common ratio? Is it 3? It goes 6 over 2. Is 6 over 2 the same thing as 24 over 6? So is there a common ratio? So what's my... Make sure you pay attention to if it's geometric or not. Same way, if it says to find a sub 7 for both sequences, then you're just plugging in 7 for the nth power. So all I'm going to do is just take 27. I'm just going to do the first one because that's the only one that's geometric. So 27 times 1/3 to the 7 minus 1 power. So 27 times 1/3 to the 6th power. What I would suggest to you is the reason why I would definitely put it in parentheses is because if you don't, it's not going, whenever you type it into the calculator, it's not going to read it correctly. Okay? So 27 times 1/3 to the 6th power is just going to be 1 over 27. Now, obviously, just like it did last week whenever we did arithmetic, they're going to get tougher because they're going to give you different types of information. They're not just going to give you the sequence and the first term. They're going to tell you certain things that you need to know. So if you're given that it's a geometric sequence, common ratio is 2, and the fourth term is 12. So if you have this information, remember you need to have for the common ratio, or for the rule, excuse me, a sub n equal to the first term times the ratio all to the n minus 1 power. The problem here is we do not know what the first term is. We do, however, know what the common ratio is. We know that that is 2. So then I still want to just plug everything in and figure out what my first term is. It's going to be a simple division problem. Because I have a sub 4 is equal to 12, what am I going to plug in for the a sub n? What number? 12. What am I going to plug in for the a sub 1? Nothing, right? Because I don't know what that is. That's what I'm trying to figure out. Times, what's my common ratio? 2. What's my n up here? 4, so 4 minus 1. So I have 12 equal to a sub 1 times 2 to the third. What is 2 to the third? 8. So I have a sub 1 times 8. How am I going to get a sub 1 by itself? Divide by 8. So what is 12 divided by 8? 3 over 2. So 3 over 2 is my first term. I'll use that to plug in right there. And all I'm going to do is just take my rule and have a sub n equals 3 halves times my ratio of 2 to the n minus 1 power. I'm not going to cancel the 2's. I'm going to leave it exactly like it is here. And I know I will have people that will try to cancel everything out. Do not do that. Okay, leave it as is. You should always have 2 parts. Unless it's a common, unless your first term is 1, you should always have 2 values somewhere. Now, the last type is when you just have 2 numbers in your sequence and you have to write the rule. So it's similar to slope, but in the fact that I'm going to have to use a root because I'm multiplying by a common value. So whenever I find my ratio, okay, what I'm going to do, I'm going to take the 2 small numbers here, so the 5 and the 2, and I'm going to take, to find r, I'm going to take the root of 5 minus 2. I'm going to take my 2 values of negative 768 and 12, and I need to divide them. Okay? Take the one that's deeper into the list. So, negative 768 divided by the 12. Okay, because everything's multiplying, so I need to divide. Similar to whenever we found the arithmetic sequence, we subtracted because everything is normally adding. The biggest thing here, the biggest hurdle for students is right here. Okay, I'm taking the root of that because I'm trying to see how many times did I have to multiply that value, this negative 768 divided by 12, how many times did I have to multiply the same number by itself to get that number? So 5 minus 2 is just 3, so I'm really just going to take, in this case, the cube root of negative 768 divided by 12, which is negative 64. So what's the cube root of negative 64? How much? Negative 4. Now it just becomes what I did before. I need to find the first term. Now, this one's probably a little bit easier because I could look at, hey, here's my second term. If I'm normally multiplying by -4 to go up, what's the first term? Like, you could definitely go back and do what I just did on the previous example, but this one's probably a little bit easier because what's the first term going to be? -3, right? How do we get the -3? We just took the 12 and divided it by the -4. Okay? It's not always going to work out that way, but since you have the second term, it should be fairly easy to go back to figure out what the first term is. So a sub 1 is just equal to -3. Now we just use the formula that we have of a sub 1 times r to the n minus 1, and we just plug everything in. So as far as my rule is concerned, it's just going to be a sub n equals -3 times -4 to the n minus 1 power.